Hi, here we are discussing energy band gap. The lowest energy level in the conduction band is noted as EC, and highest energy level in the valence band is noted as EV. Above EC and below EV, there are a large number of closely spaced energy levels. The gap between the top of the valence band and bottom of the conduction band is called the energy band gap, EG. It may be large, small, or zero depending upon the material. Here we are discussing different situations. The situation here, we can have a metal either when the conduction band is partially filled and the valence band is partially empty, or when the conduction band and valence band overlap. When there is overlap, electrons from valence band can easily move into the conduction band. This situation makes a large number of electrons available for electrical conduction. When the valence band is partially empty, electrons from its lower level can move to higher level, making conduction possible. Therefore, the resistance of such materials is low or the conductivity is high. This is the case of metals or conductors. They naturally they have a large number of electrons to participate in the process conduction. Therefore, we can say there are two possible types of arrangement in the conduction energy band gap. We can say that either these are partially completed filled, or we can say that they overlap. The conduction band and valence band overlap so that they can participate in the conduction process. And there is no need of an external energy to excite the electrons to get participated in the process conduction. They naturally they can have the characteristics to participate in the conduction. In this case, a large band gap EG exists. EG is greater than 3 eV. There are no electrons in the conduction band and therefore no electrical conduction is possible. Note that energy gap is so large that electrons cannot be excited from the valence band to the conduction band by thermal excitation. This is the case of insulators. So, in insulators, we can say that it is very tough to take electrons to participate in the process of conduction because the energy band gap is very large. So, it is not possible to conduct this electrons situation in this case. Here, a finite but small band gap EG less than 3 eV exists. Because of the small band gap, at room temperature, some electrons from valence band can acquire enough energy to cross the energy gap and enter the conduction band. These electrons, though small in numbers, can move in the conduction band. Hence, the resistance of semiconductors is not as high as that of insulators. This is the case, we can say there is a possibility of conduction because of the small energy band gap.